All right, when we last left off, we had finished the citric acid cycle. We had made a little bit of ATP, but mostly we made a lot of these high energy compounds. We also, if you look back, we also made some of those high energy compounds in glycolysis. So now is the time to use those. We are going to take those high energy compounds and we are going to put them into the electron transport chain. Now, if you'll notice, I've put these proteins here in the mitochondrial membrane. So this is the it's a phospholipid bilayer, just like our plasma membrane. And so in the top part, we're going to have these proteins, and they are going to be very, very important. Okay. So this happens, electron transport chain happens in the mitochondrial membrane. So mostly in the space of this membrane. All right, so I'm going to kind of just zoom in so y'all can have just a better look at what I'm working with here. All right, so now one thing these high energy compounds have in common is that they all have hydrogen. Okay, and that is really important because in these high energy compounds, we're actually storing that energy in that hydrogen bond. So the first thing that's going to happen here is we're going to take that high energy compound and we are going to break it up into electrons and hydrogen. Now, I need to use two different colors for these just so that you guys can see. So I'm going to make hydrogens brown, maybe. All right, and hydrogens are henceforth just little pluses because hydrogen is a positive ion. All right, so when I take those high energy compounds and I break it up into an electron and a hydrogen, this electron has so much energy, it's just going to bounce from one of these proteins to another one. And when it does that, this is going to get rid of just a little bit of energy at a time. So think of it as every bounce on these protein trampolines is going to release a little bit of energy from that electron. And as that happens, we are going to then pump all these hydrogen ions into this mitochondrial space. All right, so now what we've created is an electrochemical gradient of hydrogen ions. And now we just can't have this little electron just floating about. So we got to do something with him too. But he's out of energy. He's bounced all those protein trampolines and he's used the energy to pump all of those hydrogens in there. And so it's pretty useless, but it just can't be sitting out there doing nothing. All right. So we have an electrochemical gradient. And what do we know about things that are at high concentrations? If things are at high concentrations, they tend to diffuse to lower concentrations. And so the way this works is these hydrogen ions, let me get my hydrogen pen. These hydrogen ions are going to diffuse through this funny looking protein. This funny looking protein is called ATP synthase. ACE means enzyme, and it's a protein. Synth means to create. And what are we creating? ATP. So all those hydrogens start coming through and they provide the energy to create ATP. Now, how do you create ATP? Well, remember, we would have had ADP sitting out here and a phosphate just kind of hanging about over here maybe. And so when that hydrogen goes through the pump, it's just going to add these two things together and create ATP. So the ADP and the phosphates are just hanging about because when we break up ATP, when we use ATP, we break it up into ADP and phosphates, and they just float around in the cytoplasm ready to be ATP again. Remember the ATP cycle we did at the beginning? All right, so now we made ATP, and actually this happens so often, we can create 32 to 38 ATP per turn, okay, or per sugar. Now, remember I told you we just can't leave these electrons just sitting about. So what we're actually going to do is we're going to take that electron, we're going to add it with some oxygen, and that is going to make water. So oxygen is the final electron acceptor, and it makes water. Okay? All right, so chemical formula time. We took high energy compounds and we added oxygen, and what we created was water and then 26 to 32 ATP. I know I said more before, but I was actually giving you a total before adding everything up. Because if you add up the 2 ATP that we made in glycolysis, all right, with the couple of ATP, 2 to 4 ATP we made over here in the citric acid cycle, then you're going to add into between 30 and 38 ATP, and every cell is different. So more efficient cells will make ATP, will make more ATP, and less efficient or slower cells will make less ATP. Okay? So that, all of this that we've been doing is all cellular respiration. We just are taking the food we eat, sugar, and turning it into ATP at the end.